Okay, we're going to next talk about the ratio test. Okay. Ratio test deals with a sum of this form. Oh, don't put those on there anymore. Okay, we don't know. It could be alternating, it could be whatever. Okay, and what we're looking at is we're going to consider the limit as n goes to infinity of the absolute value of an plus 1 over a sub n. Okay, if that equals L, now, if L is less than 1, we get a convergent series. Okay, if L is bigger than 1, we get a divergent series. If L is equal to 1, we don't know. It's inconclusive. Okay, that's the ratio test. So let's take a look at an example. Let's see, for example, let's take the sum. N goes from 1 to infinity, n over 2 to the n. Okay, so our a sub n is n over 2 to the n. We're going to take the limits as n goes to infinity, an plus 1 over a sub n. That's an ugly a sub n. There we go. Okay, that equals the limit n goes to infinity, n plus 1 over 2 to the n plus 1 times, we flip the other one, 2 to the n over n. So that's going to become 1/2, which is less than 1. So this converges. Oh, this should be in blue. Okay. Now, let's just take a quick look at some, sorry. So, this one works great for things like, that are geometric. It's actually what it's built on, okay? But for the P series, this kind of fails, okay? It's inconclusive, okay? So let's just sort of consider sum n goes from 1 to infinity, 1 over n to the p. Okay? A sub n is, of course, 1 over n to the p. And the limit as n goes to infinity of a sub n plus 1 over a sub n equals the limit n goes to infinity, 1 over n plus 1 to the p times n to the p over 1. Okay, so that's going to always equal 1. Okay, so you can see now that, yeah, this, this doesn't tell us anything here for the ratio test. Okay, so I just wanted you all to see that, these tests, sometimes you have to figure out what's the right one to use for the given problem. Okay. Okay, let's take a look. We got one more, and that's the root test, and I'll do that in the next video. Haha.